Ever pondered over what happens when your computer juggles tasks? Well, it's all about context switching. Now, what exactly is context switching? Let's dive into two varieties: thread context switching and process context switching. Thread context switching is the act of storing and restoring the minimal collection of values used for the execution of a series of instructions. It includes values stored in registers in memory, such as a processor context and a state. Now here's an interesting fact. Since threads share the same address space, thread context switching can be done entirely independent of the operating system. It's akin to a swift race car driver, navigating a complex track with precision and speed. On the other hand, we have process context switching. This involves not just the thread context, but also the values stored in the memory management unit, or MMU registers. It's a more extensive process, the operating system to step in and play its part. Picture a well-coordinated team of engineers building a skyscraper where every plan, blueprint, and movement must be perfectly synchronized and timed to construct a towering masterpiece. However, this harmonious melody comes at a cost. Process switching is generally more expensive as it involves getting the operating system in the loop. Think of it as having to pay for each engineer in the construction team. On the other hand, creating and destroying threads is much cheaper, just like our ballet dancer who can perform solo. But there's a trade-off. Threads, sharing the same address space, are more prone to errors. There's no support from the operating system or hardware to protect threads from using each other's memory. It's akin to a race car driver who, while fast and dexterous, runs the risk of making a mistake and crashing if not careful. On the other hand, thread context switching may be faster than process context switching. The cost of a context switch is comparable to purchasing a ticket to a race. Direct costs are the actual switch and executing code of the handler, paralleling the price you pay for the race ticket. Then, there are the indirect costs, resulting from disrupting the cache, similar to the travel and accommodation expenses you incur to be present at the race event. In conclusion, context switching is a captivating process that enables your computer to multitask efficiently. Whether it's context switching, mirroring the intricate planning and strategy of a race, or process context switching, paralleling the complex coordination of a construction project, each has its own strengths and weaknesses. Grasping these nuances helps us value the elaborate coordination and planning that invisibly unfolds in our computers every day.